Hi, everyone. Thank you for joining us today for today's webinar with the Nature Conservancy and IBM. We as IBM are really thrilled to be collaborating with this Tech for Good event with the Nature Conservancy, a nonprofit organization that focuses on creating a world where people and nature could thrive. The Nature Conservancy in New York is interested in advancing sustainable water resource management in New York. The goal is to increase the ability for state, county, and local stakeholders with local technical expertise to connect and discuss water governance. So super excited to have you all here today. And when we talk about water governance, we're really talking about the political, social, and economic and administrative systems in place that influences water's use and management. So essentially, who gets water, when they get it, how, and this is really important to be as effective as it possibly can be. So for today's session, we will explore and learn about the Nature Conservancy, how they see the problem, and one angle on how they approach it. But really our hope and desire for all of you here today is to feel inspired by the work the Nature Conservancy does and help advance their mission, or if you find other innovative ideas in water management overall, how you can contribute to this through Call for Code, which we'll get into and describe to you what it's all about. So it's going to be a great session. We have a great lineup here in terms of the agenda for today's session. We're just going to do introductions here from the wonderful Niraj Swami. He's the Senior Director of Conservation Technology Strategy and Enablement. I'll talk a little bit about Call for Code. I'm Gilda Doria. I'm the Ecosystem Manager for Call for Code here at IBM, working very closely with different partners all across the globe. George Schuler, who's the Director of Water, will take us through the art of the possible. So what is Finn, one of their virtual facilitators within the water management space? We'll brainstorm together with Upkar, who is our fantastic technical resource here at IBM. Just what are some different technologies that you can explore and think about as you think about your submission into the challenge? And then, where do we go from here? It's time to innovate. You've learned a lot in today's session. How can you apply it into the global challenge? So with that, just wanted to make one thing known. We have a lot of facilitators in the chat. So if you have any questions, please feel free to dive in. We have experts from the Nature Conservancy as well as our team from Call for Code in there. They're here to help. We pop some links in the chat, but we also have a Get Started button located at the bottom. So if you want to join the community, you can click on this link. It'll take you directly into the Call for Code site and show you the steps on how to get started. So with that, I would love to hand it over to Niraj just to discuss, what the Nature Conservancy is all about, and also just how they're leaning into technology as an organization. Niraj.
Thanks, Gilda. Yes, again, remind everyone, we are a global organization focused entirely on the intersection of people and nature. And I am a technologist. Before coming into DNC, I used to build stuff. I still build stuff. I'm a serial entrepreneur. I've worked a lot with IBM Stack and the other stacks out there that let you think about some of what we can do. And TNC gave me a vector to think about and applying technologies, emerging as well as existing kind of models to new arenas. The reason is it's got a plethora of resources to really dive deeper into. Just some ecstatic numbers here, right? 70 plus conservation regions and more than countries and territories is where we have work. And that's not just, we're not putting pins on maps. We're talking about people on the ground, working with local folks, governments, policymakers, educators, citizens, stakeholders to really advance our mission. We have more than 100 marine conservation projects. So the whole idea of, we're here to meet and talk about water. It's water everywhere, and really thinking about ways to understand blue carbon, understand ways where we can interact and understand the impact we're driving by protecting marine regions. We have a huge scientist base. Our brain is 400 plus scientists strong, great thinkers, collaborators that give us technologists, great vectors to think about. And land, big area where our work intersects with respect to protection, which is number one priority of PNC, is protecting land and water, and simultaneously providing food and water sustainably. Over 125 million acres of land. That's a lot of land, a lot of resources, a lot of data sitting in these assets. But the real challenge here is, not looking at just the volume of data, but the breadth of this social network of nature, as I call it. There's various stakeholders involved that touch nature and the problem where we as an organization are trying to solve. But more importantly, I think drawing connections, helping them learn with each other, connect with each other, and build off of their inquiry process is a big step forward. And I'm excited to have George Schuler from our New York chapter talk a lot about the vision of what he and team have around Fin, and just really open the conversation up to the greater community. Our partnership with IBM has been special across a lot of arenas. We've done design thinking together. We've worked together with Call for Code a couple of times now. We've thought about the issue of water and conservation and monitoring impact together. It is beautiful to see how the whole situation engages, the communities engaged together. So with that, I'd love to move this forward to George and team to kind of get us deeper into what we can do here together. Thank you, everybody. Thanks, Gilda.
You're muted, Gilda.
My apologies. With that, I'll hand it over to George for the art of the possible. What is Fin? Where do we go from here? What are some ideas that we can explore? So George, Director of Water at the Nature Conservancy, I'll hand it over to you.
So I'm going to go over a couple things here. I'm going to set out the water crisis that is global, the challenges, what make it such a wicked problem to solve for humanity, the Conservancy's idea around a solution, and then some of the things we're providing you for in terms of data and resources for Call for Code. Next, Gilda. So the water crisis is really profound and entirely global, even though my focus is in New York State with my team. Over 1 billion people lack access to water, and nearly half the world's population doesn't have enough water for at least a month of the year. And many of the water resources, rivers, lakes, streams, wetlands that keep ecosystems thriving and feed the planet are drying up or becoming too polluted to use. And lastly, when you think about climate change and climate crises, the climate crisis is really a water crisis. 9 out of 10 natural disasters linked to climate change are water crises. They are droughts, or they are floods, or some combination of those. Next, please. And the challenge of this, the thing that makes it so difficult to deal with on the ground is that our regulatory, financial, government structures, our own human stakeholder interests, the people that have either a business interest or a social interest in water, mean that we have put water and how we manage it into different silos. We think of drinking water, we think of water for public health, we think of wastewater, we think of stormwater, but they're completely separated in these separate silos. And these silos of data and management and people, which never talk to each other, are reinforced at every level of our society. And this is true around the world. Federal laws, state water rights and regulations, fragmented local utilities that provide water, build the infrastructure for water, city agencies, and even community and stakeholder interests are all completely siloed. Next, please. So securing sustainable water for all, and for New York and for around the world, kind of revolves around breaking these barriers. Breaking down these barriers amongst the agencies and stakeholders who kind of hold influence or are impacted by them, creating widely available and accessible and usable information, and having more institutional coordination and capacity, more participation by people across those silos to solve those problems. Next, please. Is it stuck? So the presentation might be stuck, Gilda. You might be frozen too.
Yeah, I think Gilda it might be having connection issues. We'll wait for a second. Oh, I think we have her back now. There we go.
So I'm going to give you a description of the problem in real life terms. So Sally is a member of the town board of Confluence, New York. She's an avid gardener and enjoys early morning walks around the local lake with her dog. Lately, the lake has had algal blooms every late summer or early fall, which means that nobody can use the lake. It's dangerous for pets and people to be in. It also means that it kills fish that are in there. And there are several new proposed businesses that are coming to the town of Confluence, and some will be drawing water from the watershed that feeds the town's water supply, or they'll be buying water directly from the town in that water supply. The town doesn't know how to kind of assess what impacts these new businesses and that water use will have on their water supply for residents, for future economic development, or even for how do they weather droughts and floods. The other thing is that the town needs to kind of assess where its water supply is, but much of it is in other towns beyond its jurisdiction because the watershed is upstream. And they've also been having to put in place water restrictions and water bans every summer because of water shortages. And they just don't know how to wrap their heads around these problems. Next, please. And while Confluence, New York is a fictitious place, it's actually in a game we built to kind of be a good fictitious place, but it mirrors real life. Communities struggle collectively to manage their water resources. They lack data that they can use and understand, and not scientist data, but data that people on the ground can use to make decisions about their lives. They lack opportunity and the capacity to kind of collaborate. And there aren't ways to share their information or resources, so they often end up fighting the same battles again and again and reinventing the wheel in terms of solutions. Next, please. So the Conservancy, this is how we see the problem. And the Conservancy has a perspective that constructive solution and oriented conversations, the way to break those silos, requires good facilitation to do so. And the idea, our idea for this, which is only one of probably many solutions, is Fin. Fin as in the fin of a fish. Fin, the virtual facilitator, to help these water conversations. Next, please. So there's some guiding principles that we've thought about for Fin. And one is Fin should be a facilitator, true facilitator, not a moderator or not a question and answer bot. Fin should be everywhere the conversations are actually happening, whether it's a website dedicated to water or on some mobile app like WhatsApp, or even in SMS and MMS for places that don't have good internet connectivity. Fin should be a transparent participant in the conversation, not a secret information source on the side or confidant, and there should be a little bit of personality in that. Next, please. Fin should be a helper to spark discussion, connect people and ideas, to summarize conversations, and keep discussions and actions on track, like a good facilitator in a workshop. Fin should use words and visuals to facilitate and convey information, and should introduce information and answer basic questions using both internal data sources, and by that I mean you might have a data source connected to your own website that is hosting a Fin-like feature, or external data sources like that come from an agency website. Next, please. So the Conservancy has provided some data sets that we've used in related work. Some crowdsourced water management questions, how people actually ask for specific pieces of information about water quality and water quantity, watershed and stream geographic data, nutrient concentrations or pollution concentrations, land use and land cover information, pollutant discharge permits, which tell us where pollution is going out into the environment, whether it's clean or dirty, but it's permitted, and water withdrawals, in the New York State water withdrawals. These are all permitted, so the state keeps track of them. Next, please. And so for the external data sites, APIs exist for a lot of them. The right data, however, can be hard to find because of format or because of the way the website is built, or even figuring out what is the right data that I want out of this enormous data set. And so one challenge we also face, given how we work in the Nature Conservancy, is spatial. Where is the user located and where are they interested in, which may be the same place, maybe different places, maybe an upstream watershed and not where they're sitting. So to help you guys in your journey, TNC has provided canned data sets as a starting point, and then a Google Doc of websites, state and federal, where this data lives in the wild. So you can see how it might be deployed in other places around the country, around the world. Next, please. So that's kind of the story of Finn and the groundwork to kind of lay the foundation for thinking blue sky about how this problem might be solved.
Amazing. Thank you so much, George, for that overview. It's really great to see all the work that the Nature Conservancy is doing, and the fact that you're giving us the data sets and the resources to brainstorm and iterate further on it for the Call for Code Challenge is really exciting. So now I want to transition into Let's Brainstorm. So you just heard about the art of the possible with Finn, some guidance around how the Nature Conservancy is approaching water management. I'm going to hand it over to Upkar, our technical leader for Call for Code, to take us through what might we be able to build for Finn and just in water management overall as we look to innovate. So Upkar.
Great. Thank you, Gilda. Let me share my screen real quick. Okay. Wonderful. So I do want to keep the chat visible as well while I do this. Give me 1 second, please. All right, great. So hi, everyone. My name is Upkar, and before we dive into the different tools that are available on IBM Cloud that you can use for this project, I am curious. I'm curious to know how many folks in the audience have worked with IBM Cloud. Let's start off with that, and you can put your answers in the chat. IBMers welcome to answer as well. Yep, that's right. Thanks, Gilda. All right, no, I'm just it gives me an idea of who's attending. I do see some familiar names from our other webinars, so thank you for joining back. Yep, Ned, thank you. Lisa, you haven't. Okay, today will be a good introduction. Okay, couple of you have. Great, thank you. Okay, so my next question then is, how many people here have worked with Watson Assistant, or know of Watson Assistant, or know what Watson Assistant is? All right, let's get some answers on Watson Assistant. That's what we'll go through today. Yep, thanks, Alan. So Watson Assistant is ideal for building something. I'm going to get my picture off the screen now. For building something like Finn, right? So Watson Assistant, Rena, you worked with it, great. So Watson Assistant is used to build conversations. I wouldn't even say chatbot. It's a lot more and bigger and encompasses a lot more sort of use cases than a simple chatbot. Amit, thanks for trying Watson Assistant. Would love to know your thoughts later. So there is a Get Started button at the bottom of your screen. So if you don't have an IBM Cloud account, so I'm guessing folks who answered you do have, but if you don't have an IBM Cloud account, or if you're not part of the Call for Code community, you can click on that button to get started. And that'll take you to a page where you get a free IBM Cloud account, you get invitation to our Slack channel, where George and Gilda and Michael, everybody's hanging out, so you can go and ask questions, Kathy as well. So do join that channel, ask us questions that you may have about the data. As George pointed out, the data sets that have been shared with you, it can get overwhelming. There's a lot of information there. And so, it's my trick with hackathons is to ask often and ask early, right? So that's what I would advise you to do as well. If you're spending more than an hour on a problem, go to the Slack channel and ask. That's what we are there for. All right, what's the Slack link? Michael, if you're still there, please do share the Slack link. But otherwise, if you go to Getting Started, it'll take you to the Slack link as well. All right, so I want to show you a couple of things today. Let me make this bigger. All right, the first thing I want to show you is once you do get to the call for code landing page, we do have three. Let's go to the global challenge. All right. So we do have, once you join the community, do all that good stuff, you can access a lot of resources. So, the team has provided you with the data sets, but then we have also created these starter kits for you to look at. And the one I want to talk to you today about is the Clean Water and Sanitation Starter Kit. So I'm going to click on that. And within that, I want to, you can read through this. There's a lot of good information here from our SMEs. So if you want to learn about the problem in general, read through all of this. I'll focus today, since I only have about 20 minutes left, 25 minutes left. We'll focus on the resources and specifically the technical resources that have been provided with the starter kits. So the first thing here is a NodeRed application. If you haven't worked with NodeRed before, NodeRed is a low-code flow-based programming, and essentially what the idea is you drag and drop different pieces or different nodes onto a canvas, and then you hook them together to create your program, right? So it's ideal if you, I saw a comment, somebody's looking for a programmer to join their team. In the meantime, while you are looking for that programmer, you can go learn how to code, and also you can use something like NodeRed to start your journey, to start your project. And when you do get that programmer, you can always take the NodeRed concept and convert it to a more traditional sort of programming. So that would be my advice. So do take a look at NodeRed. I'll open that resource for you here. This is created by our senior developer advocate, John Wallachy, who's not here today. But if you have any questions around this, he's also in the Slack channel that I mentioned before. All right, so at the end of this exercise, you would create something like this, which is a NodeRed based dashboard. And it's a little bit small to see here. Let me see if I can make it a little bit bigger. For some reason, the picture doesn't. Oh, here. Okay, this is big enough. So you can see here, this NodeRed based dashboard is showing you different kinds of maps, or is mapping data onto this map at the center. And then on the left here, you can choose different areas that you want to map onto that centerpiece. And then on the right here is a list of contaminants that are found in that area. So you can, this is a very simple dashboard to get you started. And it's showing the different pieces working together. And you can click on these different rows and bring up the details for that row. Okay, so that, again, if you follow this exercise, it goes through a couple of different pieces. It talks about GeoJSON, what that is and why that's important. You would need to understand that. A lot of data that George shared with you has that format as well, so it's good to learn about it. And then it goes through a couple of different APIs and where you can get this data from. So this, together with what was provided before, it's a lot of good data sets that you can work with. And then there's also an API. So, there's the raw data, but then there's also APIs that in one way or another maybe consolidate that data or help you get to it easier or help you query that data set. So it talks about that as well. Okay, so that's NodeRed. That would be my, the one thing to look at as you're developing solutions for this challenge. The other thing I would want to show you is once you get into IBM Cloud, once you log in, you're brought to this page, and this is your overall dashboard for your IBM Cloud account. So dashboard shows you the different services you've created. If there's any alerts and notifications and things like that. There are two more links if you've never been to IBM Cloud that I would bookmark or know about. So the first thing is the resource list, and this is all the resources that I've created so far. And you can see here, I do have a Watson. Let me make this a little bit bigger. There's a button here. Oops, I did not want to do that. Give me 1 second. Large text. Okay, slightly bigger. So you can see here, I already have a Watson Assistant service created. All the services that I'm showing today do have a light tier, which means you can use it for free. You don't have to provide a credit card or anything like that. So you can see I have Watson Assistant, I have something called Watson Studio, and a bunch of other AI services, so language translator, machine learning. Now, you might be wondering, okay, so what else is provided on IBM Cloud? That's the second link I want to I want to show you today, which is the catalog. So on the top, you can see there's the catalog. You can go in there. There's a filter on the left. You can filter by different categories, etc. So what we are interested in today is using Watson Assistant to help build a conversation. And I'm very intentional when I say it's used to build a conversation and not a bot. And when I show you the assistant piece, then I'll also go into why I'm so intentional on that. All right, you can see here there's a light here, so you can click on that and then click on create. Now, the create button for me is not active, and the reason is I already have a light plan. So you can create a light plan, but you can only create one light plan of a service. So I would have to delete the other one to use this, but I'm just going to use the other one instead. All right, so Watson Assistant used to build bots. That's one thing I want to show you. The other thing in catalog, in all of these projects that I see coming through, there's always data that people want to store. And there's a number of different services. So what we'll do is we'll go to databases, and then we'll say, I only want to see the light or the free one. Actually, only the light tier. So these are the two databases to note here. The first one is Cloudant. And the Cloudant database is a NoSQL database. So if you think of something like Mongo, so Cloudant is based on Apache CouchDB, which is again open source. As you can see, IBM is big on open source. So Cloudant is a managed version of Apache CouchDB. You store your documents or you store your data in what are called documents, and documents are simply JSON objects. Very easy to query. The what's interesting to you or should be interesting to you in this challenge is Cloudant supports geospatial data. So it supports things like geofencing. It supports things like given a point, does this point fall within a enclosed data set or data points, right? So it supports a lot of different queries that you can do. So if you go look at the data, the API that George shared with you, if you find something interesting there, you can bring it into Cloudant, one possibility. And then with Cloudant, then you get these geospatial query abilities. It supports, so it understands geospatial data and supports the different kinds of geometries that can be created with that data set. Okay, so that's something I want to point out. Again, 20 minutes, 25 minutes is not enough to sort of go through it in detail, but I want to give you enough resources so you can go explore yourself, and then of course come to us in Slack and ask questions. All right, and I am not keeping an eye on the questions. Let me see. All right, no question. Gilda, feel free to interrupt me if there are any questions. I can't see the screen. All right, and the other database I want to point out is the traditional relational. So if you want to go that route, and you might need that relational database, then there is a free tier in the IBM Cloud for DB2. All right, so we covered databases, a little bit of I showed you a little bit of AI, and then NodeRed as a low-code solution. And then one more data storage option is the Cloud Object Storage. Let me bring it up. So Cloud Object Storage is an S3 compatible object storage on IBM Cloud. Also has a light tier, and you can use this if you want to store unstructured data, right? So if you think of, so it's not really NoSQL, it's not relational, but it's video files or audio files or something like that. You can put into Cloud Object Storage, and then it gives you a standard API in multiple languages to grab that data, search that data, upload data into what we call buckets in Cloud Object Storage. So again, if you have any questions around that, you can come ask me in Slack. But since I mentioned APIs, you'll see this is very common in all of or most of IBM services, including Watson Assistant. When you click on API, well, there are two different. One is the docs, and docs will show you, will help you get started. It might have a sample or tutorial. And then API is more around the different calls you can make using different SDKs. And for most products, this is very common, or for most, I should say, services on IBM Cloud. There are SDKs in Java, Node, Python, Go. I also see sometimes Swift and PHP. So you can pick your language of your choice and work with these services. And then there's also this curl. So if you don't see a language here, as long as you can make HTTP requests and pass in your API key to make it secure, any language would do, right? So, all right. So that's storage. NoSQL, which is Cloud End, DB2, which is relational, and then Cloud Object Storage for everything else. In terms of, well, let's go now. I'll dive into Watson Assistant. So let me. So I had it open yesterday, and then I shut it down. This one here. All right. So we do have another. This is Starter Kit from last year. And I bring it up. It's a different topic. So it's a bot that was built to answer questions around COVID. But I bring it up because it does have a lot of the Watson features that Watson Assistant features that I want to show you. Okay, so I'll share this in the chat as well if you want to try it out on your own. But this is a tutorial, right? So the concept is you're building a bot right here, Watson Assistant. You're building a conversation that people can come and ask questions around COVID. And then it uses something called IBM Cloud functions, okay, through the concept of webhooks. So Watson Assistant has this thing called webhooks, and it can make calls to external endpoints using webhooks. And the endpoint lives in Cloud Functions. So Cloud Functions is Apache OpenWhisk based function as a service, if you've heard of that term, FAAS. So Watson Assistant will try and answer questions that you've taught it how to answer. And then for questions it doesn't know answers to, it'll go reach out to functions, and then functions can reach out to other APIs and data sets, right? So again, connecting the dots here, the data set that George provided you, or the APIs that George has given you in that Google Doc, functions can reach out to those APIs, or you may store those data sets in Cloudent, and then functions can reach to Cloudent to retrieve what it needs, and then answer back through Watson Assistant to the end user. Right. In this case, the bot, the chat bot or the chat is surfaced through a Node.js web app. But again, Watson Assistant, it'll work with Alexa, Google Home, SMS, using Twilio integration. So when you think about, for me, it's like connecting. It's a puzzle, right? So it's connecting different pieces to create your solution. So in this case, these are the different pieces that are being used. You also see this service called Discovery. And Discovery, I think of it as to extend my chatbot to make it a little bit more smart than a typical Q&A chatbot. And George, when he was explaining the problem, he talked about facilitating, right? He talked about not simply a Q&A bot where people can go and read the answers off the net. And so services like Functions, Discovery, Cloudent, other AI services. For example, we have a service called Tone Analysis on IBM Cloud. And that service, actually, let's go look it up, cloud.ibm.com, catalog. So I've memorized that. And if I go to Tone, again, the session today is not to show you a solution, but give you enough ideas to go create solutions of your own, right? To spark that thinking, hopefully, in you. And then you can, again, I keep repeating it, but come ask us questions on Slack. So you can see here, tone analyzer, it basically given, if I go to docs, right? So in here, tone analyzer, given a sentence, it'll come back with different tones. So, if the person, or if the sentence, I should say, what's the sentiment? Is it sad? Is it happy? Is it angry? Is it disgust? A lot of people use this with the chatbot. So you can, if I go back to this diagram, you might have Watson Assistant call to functions, call to tone analyzer, and return back, right? So if on a chatbot, the user seems frustrated or disgusted or angry versus joyful or happy, you may want to give a different response back to the user. And that's bringing another machine learning piece from IBM Cloud into the picture. And the machine learning pieces, or the AI pieces I'm showing you today, I call them more of the black box APIs. So I don't have to be a machine learning person or data scientist in order to use the service. I don't need to understand the math behind it. I can train it, so I can give it data, train it, and get some result back. That being said, if you are a data science person and you want to create your own models and test your own models and deploy your own models, that's fine as well. There's a service called Watson Studio. You can come and ask us about that as well. That lets you create open source models. So if let's say you're creating a model on Keras or TensorFlow or PyTorch or just scikit-learn, you can create those models and deploy using Watson Studio. Okay. So again, a lot of terminology flying around here, and I'm afraid I might lose some of you. So I'm going to dive into the demo now. So again, follow this later. But what we'll do now is, let's see, I want to, let's go here. Okay, here. So here are the steps to follow, right? Create an IBM Cloud account. I already did that. The next step is create a Watson Assistant service. Since I already have a free one created, it won't let me create another one, but I can go to my resource list and launch what I have. So let's go to Watson Assistant, click on that, and it should come up. Let's see, any questions? No questions. Is anybody listening? Anybody still here? Come on, just say yes or no, or thumbs up, thumbs down. What do you think? Because I mean, we talk for a living, and we can talk forever. But I want it to be useful to you. So, oh, thanks, Lisa. Thank you. Yeah. If you have questions, let me know. All right. So here's Watson Assistant. So we launched the service. The first thing you see is an API key and a URL. Important stuff. So when you are integrating into Watson Assistant, or when you're using the API to do anything with our services, you most likely need some sort of API key and URL. So you can download these, or you can save it somewhere. You can always come back here and see this too. So I'm going to launch Watson Assistant, and we'll pull in, instead of building one from scratch, we will pull in the bot that was on this pattern. Now there are two things with Watson Assistant. Quickly, first thing is Assistant, and that's what shows up at the end of the day, right? That's what gets installed on your website, and what people interact with. And then there's something called skills. And think of skill as the conversation. So that's the dialogue, that's the back and forth. That's where the machine learning magic is happening. There's a lot of natural language processing happening in Watson Assistant, and I'll give you examples of that. So first thing I'm going to do is create a skill. And then I'm going to create a dialogue skill. The action skill is in beta. So let's go with the dialogue skill here, click on next. And instead of creating a skill from scratch, I'm going to upload. And what I've done is I've just, let me close this out. This out. Let's see. Here. So I've cloned this repo locally on my machine. So I'm going to upload, and you can see here, this is the solution starter kit. This is my cloned repo. Go to starter kit, and then I'll go to Assistant. That's where my skill lives. And I'm going to import this JSON file, open, and upload. This is importing my skill into Watson Assistant. And you're brought to this screen. Again, quick, I don't know, have you seen those books that say learn Python in 2 hours? So this is learn Watson Assistant in 2 minutes. Those books, I don't believe in those, but I believe you'll learn this in 2 minutes. So there's this concept of intent, and intent says what the person is trying to do, what your user is trying to accomplish today. That's your intent. And there's something called entity, and entity is basically, think of it as a noun. Think of it as what the user, it's the topic of discussion or concept. That's for example here, a phone number is an entity. The reply of yes or no is an entity, right? And we'll use this later in our dialogue. Speaking of dialogue, here's what a dialogue looks like. So since we imported this conversation or a skill, we already get some dialogues. But if you were doing this from scratch, this would look, this would just have the welcome node. These things are called nodes. So in the dialogue, every card here is a node. And what happens is when you send something to Watson Assistant says, okay, what is the user trying to say? So that's where the natural language processing magic is taking place, right? I mean, it's magic for some, for the end user or for me, but it's just data science and machine learning behind the scenes. So what happens is it says, hey, if I think the user is talking about this thing called greeting, then I'm going to respond with, hello, I'm COVID crisis communication bot. I'm here to answer your question. Now, again, don't get tangled up in the use case here with COVID. Think of how this could apply to the problem at hand. All right, so that's my greeting node, and like I said, the first thing that happens is it tries to gauge what is the user talking about. And so if I were to go to this greeting intent now, right? So if I go to intent and click on greeting, where's greeting? Greeting. What happens here is, so you can see these are the different ways users can say hello or can greet, right? All these examples fall into the greeting category. So this is where it uses some algorithms and models behind the scene to say how closely what the user is saying, how closely does that match the intent of greeting. And for you to get a closer match, and for your Watson assistant to get better, you have to give it more data for it to learn with. And so that's why you see all these examples of how a person can say a greeting. And you can see the other ones here too. For example, let's see here, employee shows symptom, right? So here we have provided different examples of how a person may ask about symptoms with their employees, right? There's another one that we'll use here. It's the risk to pets. Right, so is my pet at risk? Can coronavirus affect pets? So I may add another one. Can my dog get the virus? That might be another thing so I've added a new example, and so Watson behind the scenes has started training the model or has started training, and I would say improving, right, the model to understand something like, can my dog get the virus? So that's intense. We talked about entities. We talked about dialogue. Those are the basic pieces, the very fundamental pieces that go into building a skill in Watson Assistant. And then there are a lot of other features that are really cool. So before I get into the more advanced features, once when you're trying this out, or when you're setting up your bot and you're building your conversation, you want to try it out very occasionally, right? You want to see if it works or not before you deploy it to your website. So there is the try it button, and you can use that. Excuse me. You can use that to see what you have built so far. So you can see the first thing it says is, hello, I'm the COVID bot, right? So what happened is, if I go to dialogue, it's already hit this first greeting. It's already hit that. If I at this point were to say hello, then it says that again, right? So and when you hover over these things, it tells you where the bot is in the dialogue. So you can see this thing is highlighted blue. That's why. So it's in that node. If I were to say bye, right, it says farewell. And if I click on this map icon, you can see the blue thing move to goodbye. So it understands that I said something that matches the intent of saying goodbye. All right. So now I can start asking it questions. So remember, you put in that thing about the dog. Let's ask it something similar, but not exactly that. So maybe I say, can my dog get sick? Right. I think the intent was, can my dog get the virus? So if I ask it, can my dog get sick? It understands that, okay, I'm going to match what the user asked to risk to pets because it looks or sounds very similar. If I say, can my dog jump? Oops. Right, so it's like, I don't know the answer to that. Even though I used the word jump, or sorry, the word dog, it doesn't match it to that intent, because I'm not asking if my dog is sick or has the virus or what are the effects or symptoms of two animals. So that's how the machine learning part of it works, right? So all of these are predetermined answers to my questions. So this is the base, right? So this is the sort of FAQ kind of bot. Now, where can we take this from here? That's where this whole idea of Webhook comes in. Okay. So if I want to ask a question like, how many cases, right? So how many cases are there worldwide of coronavirus? in our COVID. And so if I click on that, or if I send that a question, it comes back with these are all the cases, and it pulls these numbers from somewhere, right? So that's where we didn't hard code these numbers because these numbers change on a daily basis. We were calling an API to get these numbers, and this is where, going back to what George said, this is a little bit more than the simple FAQ bot. It's not exactly facilitating, but it's leading there, I would say. And so how would I do something like this? So if you go to options, there's this idea of passing in a webhook, and you can see here it's calling this endpoint. That's all it's doing. It's calling this endpoint, and whatever result comes back, it's going to show that result here. And if I go back to dialog, and I think it's here. Yeah, so in here, if I had asked what's the latest news on COVID-19, it would have called my webhook again. You can see here webhook. And then after it calls my webhook, whatever results come back, it's just going to show that. There are lots of other cool features too. So for example, there's a feature called digression, which is, as I'm talking to you right now, if you were to raise your hand, right? If you were doing this in person, you raise your hand and you say, hey, is there a bathroom? I need to go to the bathroom. And then, you go, you come back, and we start talking again about webhooks and Watson Assistant. So that's the concept of digression, and it's built into Watson Assistant. So you can go away or digress from a conversation and come back to it. There's a concept of slots.
Oh. Sorry to interrupt. There's a question in the chat.
Okay, Alec, for the bot for answer, can you show more detail when the user wants to know where total cases number comes from? Absolutely. So it's not built in right now. But you could possibly, well, there are a couple of angles to that, right? So you could, if the user was using a phone, you might have their location. So you might say, hey, it looks like you're located here. These are the worldwide numbers. And by the way, in the Bay Area, this is what, or at a county level, you can say, it seems like you're chatting from here. Here are the numbers for your location. Or you could then use what I was saying before, something like slots, where you can, after this, you can say, these are the worldwide numbers. By the way, where are you from, or where are you located? And the user gives you a location, and then you can go look that up. So that's the idea of slots. It helps you collect information from the user in a very natural way. And then they've built these. They're very clever. They've built these little things in Watson Assistant where your response can vary. So you can tell it 3 or 5 different responses that you want to give, and then you can randomize it. So every time the user comes and talks to your bot or to Finn, it looks like it's a different response, right? So it's more natural the way we interact. Also, you can send back pictures, movies, like little images. People use GIFs a lot. That gives your bot a personality, right? So it's not a very text-based bots. So you just think of how you can use all of this. Maybe you show a map back. If you're using there's this concept in Watson Assistant. Again, we don't have time to go very much in detail, but the concept of user-defined responses. And so with that, what you can do is Watson Assistant can send back an interactive response back to the user. So maybe you send a map back where the user can click around and get more information from the map, or at least be able to zoom in and zoom out, right? You can customize CSS and JavaScript and send back widgets to the user. And then when the user interacts with that response gets sent back to Watson Assistant, and you have another conversation going on based on what the user selected. So yeah, there's tons of different features we can use here to make your bot more natural, more of a facilitator, less of just a lookup bot, right? So all these little tricks. And then, okay, so you have your webhook. The last piece I want to show is the webhook. As was shown here in this picture, the webhook is calling a function. So let me show you what that function looks like. So again, I'm back in my IBM Cloud. Let's go back here. This is my landing page. If you click on the little hamburger menu, you can go to this thing called Cloud Functions. And then let's go to Overview. So again, this is function as a service. You can write small snippets of code and ask IBM Cloud to run it for you, to scale it for you up and down. It also provides an API gateway, so you can secure your functions, and you can do things like OAuth authentication, as well as rate limiting, like stuff that you get with typical API gateways. So what I've done is I've already got that webhook created. Let me show you what that looks like. So in IBM Cloud Functions, your code is called an action. Okay, and then there's other concepts too. There's a concept of trigger. So you can actually trigger your action based on certain events. So maybe some data gets, actually Cloudant is a really good use case, right? So if some data gets uploaded into Cloudant, you can trigger a webhook to process that data. That's an example. And there are other events too that you can listen into, not just data changes. So here's my COVID webhook, and I'm going to click on that to show you what the code looks like. This is a Node.js function. It's using Node.js 12, and it's using promises to do async operations, and then it's using this discovery API. And so what this does is, again, this is an example. All right, so here's my main function. So when the user comes into my bot, right, and let's go back here. Let's go back here. So that API, that endpoint that we defined in options, this is that exactly that cloud function. And then you can pass in like this one, right? You can pass in headers, so you can pass in authentication as well if you want to secure your endpoint. So this is the function. Main function is what gets called. And in the main function, I'm looking for a param called API. With Watson Assistant, just keep in mind that you can only have one webhook for the whole skill. And so to deal with or to be able to do multiple things with that one webhook, you can use something like params. So I'm saying if the user makes a call, or if Watson Assistant makes a call to this webhook and passes in the parameter of API, then it's going out to this, right, to this API. And when I'm showing you this API, think of the different APIs and data sets that George provided you earlier. So this is, yeah.
I just had one comment. I know you've covered so much great material, and just trying to bring it back to a high level before we wrap up. George, are there any kind of thoughts or comments just on some of the material that Upkar shared and how this could tie back to TNC's use case of Fin and some of the material we covered? So as people leave inspired, they can kind of be thinking about how it relates back to some of the concepts covered earlier.
Yeah, and so our use case in New York is that we started to build a platform for water stakeholders to collaborate on, and to visualize data in some very new ways, and to have their conversations and some tools to work on finding solutions when they can't get together, like in COVID. But we can't be in all those conversations as TNC scientists and experts, and there aren't enough experts in New York in the water field to do that. And so we're trying to find a technology solution to that, and Fin would be that technology solution. So for our platform, Fin would be the MC, the facilitator of dozens of conversations in dozens of watersheds, thousands of watersheds around the state, helping communities and businesses and governments kind of find a path forward and in collaboration. So there's a real need for this. We built out, I'll be honest, we built out a very simple prototype that was more of a Q&A bot to kind of see if there was legs to the idea. And given our testing and given the way that we reacted to it, we think this would be really helpful. But we need some help kind of imagining it, and then imagining how it would play out in Africa or India or Oklahoma or New Jersey. This thing should also be scalable. That's the thing, is the problem is around the world. Many of the factors are the same, and many of those conversations need the same help. And so the sky's really the limit for how you could develop this and how you could deploy it.
Yeah, no, thank you for bringing us back to that. Actually, it's so easy to get stuck in I wouldn't say stuck, to like go in the weeds, and that's important stuff too once you start implementing, but it's equally important to think of the use case and the bigger ideas. So Alec has a comment or a question around establishing trust with the bot. What if there are problems with the data or the numbers that are coming through? Can users flag answers and ask for human expert input? So while I know that is possible with Watson Assistant, there's this concept of agent handover where you can hand it over to a live person. do you want to comment, George, on the use case here with that question, or if that's applicable?
No, I think it's great. And in the discussion platform we're building, we have, not with the facilitator piece, but with others, we have that. So when there's clearly something that isn't factual or isn't correct or doesn't line up with the data, or someone is being abusive, there's like in many platforms a way to get a real human being to intervene. And I think Alex's idea kind of fits also with, we'd like to incentivize things. So if you are engaged in these communities and these conversations, and you're going to reach a point where you need a live person to help you, having that as part of the incentive. I've done all this stuff. I'm part of this community. I'm investing in it. I'm working with others. I'm using data, and now I need help. That link is one that we've thought of, and so I think that's a great idea as an added principle. How does that happen? How does that handoff from there's a problem with the data, or I need help and I'm beyond the bot? How do I get to a real human being, whether it's a peer in the conversation or an expert from the Conservancy or the expert from some other network?
Yeah, and so there are features in the different services that let you do that. And if that's, Alec and anybody else, if we can chat more in Slack around that.
Amazing. I know we're wrapping up in that time. Just wanted to say a huge thank you to the Nature Conservancy. This event wouldn't have been possible without their support, their vision of what we're doing within the water management, water quality space. Anupkar, to you as well, for taking us through that demo. I know we didn't cover call for code in too much detail, but I just wanted to re-emphasize the fact that there's an opportunity now to get started here at the bottom of your screen, enjoying millions of developers and innovators around the world to help solve these challenges that were covered here today. It's an amazing community. There's amazing resources that IBM can provide to you through this challenge. The challenge is running through July 31st, and you have the opportunity between now and then to submit ideas, form teams, and really get innovating on these data sources that were provided here today. So just wanted to say a huge thank you to the team here on the call, to the Nature Conservancy for the amazing partnership that we've had over the last years, and hope everyone's feeling really inspired and getting excited to get going on these issues. And with that, just wanted to say a huge thank you. Hope everyone has a great rest of your day wherever you are in the world, and stay safe. And we will be looking for your submissions through the Call for Code Global Challenge. Thanks so much.
Great. Thank you.
Bye-bye.
Bye-bye.